Mari, let me know when you let people in, okay?
You should be good to go, Karen, if you want to get started.
Did you let people in? Oh, great. Okay. All right. Well, we're going to go ahead and get started. My name is Karen Crumbaker. I'm with Colorado State University, Larimer County Extension, and I'd like to welcome you to the first of our 4 series on Wildfire Wednesdays. So the first one that we're going to be discussing tonight is fire ecology and behavior. And before we get started, I'd like to let 2 of my colleagues introduce themselves who helped put this presentation on. So Mari and Sharon, if you'd like to take a minute and just introduce yourselves.
Sure, I'm Mari Johnson. I'm the Natural Resource Agent for CSU Extension in Jefferson County, and we're happy to have you all here.
And I'm Sharon Boken. I'm with CSU Extension in Boulder County, and I am the Small Acreage Coordinator. And thanks for joining us tonight.
Okay, so just a little bit of background before we get started. Just would like you all to know that you are muted and that any questions that you have, you should go ahead and submit them into the chat box, and you'll find that at the bottom of your screen, you'll see the word chat. You can go ahead and enter any questions that you might have as we go along into that chat box. And our goal is to answer as many of those as possible when we're done, when Tony is done with his presentation. We have quite a few people on the presentation this evening, so we may not get to all of the questions, but we'll do our best to answer as many as we can. And just so you know, just to make your experience a little bit more pleasant this evening, we're going to go ahead and send out the PowerPoint presentation and the recording. So we are recording this, so we will send that out. So if there's something that you missed, just know that we will get that presentation and the recording out to you, so you'll have that. And then finally, at the very end of our series, and it's, as you can see on the screen, we've got 4 presentations that are scheduled for this month. At the very end, after our last presentation on the 28th, we're going to go ahead and send everybody a survey so that we can capture information from you as far as what you liked, what you didn't like, what you might like to see in the future, where you're from. We'd like to know where our audience is from. We're just not able to capture that on a polling during during the presentations. So we're going to go ahead and send out a survey. So hopefully you'll all participate in that survey and give us your feedback. We would really appreciate it. So with that, I'm going to go ahead and introduce Dr. Tony Chang. He is a professor and an extension specialist at Colorado State University. He is with the Department of Forest and Rangeland Stewardship. And Tony, I'll go ahead and turn it over to you, and you can go ahead and provide any additional information that you would like to the participants. And again, thank you all for being here.
Thank you, Karen. Bear with me with this transition, and here we go. Is that coming in there? Okay.
Yep, can see it perfectly. Thanks, Tony.
Okay, well, thank you for inviting me, the hosts here, and also for all of you that are taking some time out on this Wednesday. I know there's a lot of things you could be doing with your time on a Wednesday evening, and the fact this is important to you is kind of a sign of the times. And before I really introduce myself, I also want to acknowledge that these, you know, I'm sitting here in Fort Collins, and we've been shrouded in smoke for since about the middle of August. It's a very visceral experience. A lot of folks are directly impacted, maybe even suffering loss, displacement, there's a lot of fear and concern and things that are happening, and so I wanted to just really reach out and express my sympathies for folks that are really going through some tough times as a result of this wildfire, and I hope that our communities can band together and really provide support. So my name is Tony Chang. I'm, as Karen said, I am on the faculty in the Forest and Rangeland Stewardship Department with an extension appointment. And through my extension appointment, I operate two extension outreach and applied research centers. One is called the Colorado Forest Restoration Institute. And what we do is that we work with a variety of land managers and their stakeholders all around Colorado, and we have partners in Arizona and New Mexico, similar institutes based at universities. And our role is really to span the boundaries between science and decision-making and management. So we really operate at that interface, and our focus is on forest and fire management. Forest restoration to minimize the impacts of fires. And so I operate a team. Some of them are on this video presentation, and we spend a lot of time out with a variety of managers and community residents all around the landscapes in Colorado, talking fire and forest, and really trying to integrate that into management planning and decision making. The second is the Southern Rockies Fire Science Network, which is an extension and outreach knowledge exchange program that is funded by the Joint Fire Science Program. Joint Fire Science is a funding program from a variety of federal agencies to generate and disseminate fire science to inform land management, community protection, fire mitigation, and those kinds of things. And so the Southern Rockies is one here at Colorado State, and there are 16 around the country. So that's a little bit who I am and what I do at CSU. As an operator in a boundary spanning role, my job is really to be a generalist. I have a specialization in social science and working with people, conflict management and decision making. But the way I manifest that within fire and forest management, I get to touch on a lot of varieties of ecology and fire science and those kinds of things. So I sort of say that as a caveat is that there's a lot of folks that do wildfire ecology and fire science that have a lot of deep expertise, and we have a lot of resources at CSU to be able to answer some more detailed questions. I'll sort of skip over this, but just make sure that everybody's aware that this is one of a series of seminars for Wildfire Wednesdays. Okay, so in extension and in education, we like to always specify some learning objectives. So by the end of my presentation, my hope is that the audience here will be able to understand some basic definitions and concepts of wildland fire. The way I've structured this is to, because there's so many people that have registered, I'm going to really start with some very basic concepts and really try to work out from there. And so really trying to start from some ground floor stuff. And then the second objective is I'm focusing really on the high level fire ecology. What's the role of fire in our ecosystems that we see here in Colorado? And what are the conditions and factors that govern fire in our ecosystems? And then I'm going to zoom into when a fire does happen, what does fire behavior look like? What are the conditions and factors that affect fire behavior? As that's what I've been asked to talk about and present on. And then the final objective is bringing it all together. Why does it matter? Why should anybody in Colorado care? And what's really important to understand and take away? I'm a very visual person, and so I'm going to use a lot of graphical displays. I'm going to talk about something that's very elemental in fire science called the fire behavior triangle. And then I have some other visuals. The point of all that is as well is that there's a lot of complexity in fire ecology and fire behavior. it's a very robust area of science and research. And so any one of these topic areas, you can kind of dive down into a rabbit hole and really dig deep. I'm not going to do that during this presentation. I kind of want to start very general. Okay, so I'm going to start off with some just definitions and basic concepts. And the first definition I want to throw out there is fire risk. And so it's something that you may hear a lot of people talk about. Risk is a term that's very common in this wildfire world here. And we really think about risk in two ways. One is just the probability, the likelihood that a fire will start and spread. And that's kind of an objective calculation. We can actually derive probabilities of when and where a fire is likely to start and spread. There's lightning-caused fires, there's human-caused fires, and we can generate a variety of mathematical and statistical formulas to be able to sprinkle those probabilities across the landscape. In terms of wildfire management and risk management, we're really then focusing on the probability that a fire will cause harm or loss of something of value, like the threat of the wildfire coming towards us home during the Cold Springs fire just outside of Nederland, Colorado, in Boulder County. So most often when we refer to wildfire risk, we usually refer to the second bullet point here. Oops. The second term is fuel, and that's probably pretty self-explanatory. It's anything that's going to combust and sustain a fire. But when we talk about that in terms of wildfire and wildland fire, we also categorize fuels in terms of surface fuels, so fuels that are on the ground that are capable of igniting and carrying a fire. The ladder fuels, which are kind of the vegetation and other structures that might carry a fire from the ground, the surface up into the tree crowns. And so those conditions, in order for a big fire like you see on the left to be met, you have to have a lot of energy that's being combusted from the surface up into the crown. So those are just kind of some basics that I thought might be a good place to start, because I'll be talking about fuel quite a bit here. Okay, so the second objective here are conditions and factors that affect the role of fire in an ecosystem. And this is really kind of the province of the field of fire ecology. So there's a whole bunch of folks here at Colorado State University that study fire ecology, at the US government, US Forest Service, and other universities also do that. So the one concept in fire ecology that is worth really understanding, that helps us come to kind of provide some understanding for the role of fire in an ecosystem, is what's called a fire regime. And the fire regime is basically the general patterns of fire that ecosystems are likely to experience over a very long time period, over very large areas. So general patterns likely to happen over long periods of time, over large areas. So if we take a look, this is a Google Earth image of the Colorado Front Range. Down here in the lower center is Horsetooth Reservoir here and the city of Fort Collins. And then we were looking south, and up here on the upper left corner of my screen, at least, is Colorado Springs and Pikes Peak. So if we were suspended here for 500 years, 1,000 years, and we were able to see year after year all of the fires blinking, popping up all across this landscape, the pattern that we see, the general pattern we see, we would characterize as the fire regime for the Front Range. Okay, so we're talking about a fairly large area over a long period of time. And I'll get to a little bit about why that might be important to understand. And so when we talk about the patterns, the attributes of those patterns, ecologists use terms like frequency, how often this landscape might experience fire because of a variety of conditions. So they use the words fire return interval, or sometimes fire rotation, to characterize how long it would take for an entire area to burn all the way through over time. Fire ecologists and fire scientists use terms like intensity to measure the amount of energy that might be released during a fire, the type of fire, whether there's a surface fire, a crown fire, or something in between. And then also the severity of fire, which is essentially the effect that a fire is going to have on something, a measurable something, whether it's soil or vegetation or homes or communities or those kinds of things. So severity depends on what you are actually looking at as far as an attribute. So even a grass fire may be highly severe for certain attributes you might be interested in. So fire regime is, so this is our first triangle, our first fire triangle. It's a fire regime triangle, and the citation for, if you're interested in following up that, is listed below. So a fire regime is really then governed and controlled by three variables. One is ignition sources. You have to have a source of ignition to start and have a fire start. The atmospheric conditions over a long period of time, and then the availability of things to burn, of vegetation or other resources to burn. And so the fire regime of any given ecosystem is kind of in the middle and is governed by these three factors, and then controlled by these kind of long-term averages year in and year out. Okay. And so this is kind of the basics of some fire ecology and fire regime. I'm going to take it out of kind of this conceptual framework and put it into a landscape that many of us live in and see every day. And this is the Colorado Front Range. This is kind of a mock-up, a general mock-up of the elevation gradient as you go from the foothills and the plains, kind of where the urban areas are and the short grass steppe. And then as you move up in elevation, you enter into some woodlands and shrublands, and then ponderosa pine, kind of what we call dry forest types or dry mixed conifer types. You might have some Douglas fir mixed in there, maybe some juniper. And then as you move up in elevation, you have more of a mix of conifers. You might have some spruce, Engelmann spruce, or some blue spruce, maybe some lodgepole pine mixed in with your ponderosa pine and Douglas fir. There's aspen kind of everywhere throughout the range. And then you move up into a higher elevation where we see our lodgepole pine and our Engelmann spruce and fir and subalpine fir forest, topping out about, our tree line is about 11,500 feet. Okay, so if we look at then the fire regime that characterizes these ecosystem types, and we think about the factors that govern a fire regime, ignition, atmospheric condition, and fuel, we can then start characterizing the fire regime as you go from low elevation dry forest up to high elevation subalpine forest. So what we understand from a fire ecology science perspective is that historically in the dry lower elevation forest types, fires typically burned every 8 to 40 years, somewhere in that interval depending where you are. They tended to be low to moderate intensity. They might have had some passive fire, and there might have actually been some occasional high intensity and high severity patches where some large extent of trees and vegetation had burned. But we also know that these fires tended to leave a lot of trees remaining because we can see fire scars on those trees. We see very old trees that have persisted for several hundred years through multiple fires. So we have a lot of evidence to know that this is kind of what the fire regime generally look like here in the lower elevation, drier part of the Front Range. As you move up and you get to the higher end of the elevations, you have more persistent snowpacks. It's wetter, it's cooler. And so you don't have as many atmospheric conditions as you would with the lower elevation and the dry, what we call a seasonally dry climate. Okay, and so in the lower elevation, the atmospheric conditions were such that there was a lot of opportunities for fires to start and spread. But because it's very dry and it's not very productive, there's not a lot of fuels to consume. And so that's why the fires tended to be more on the surface, moderate intensity, and occasionally would get into maybe a ravine or something and have more forests to burn. But as you move upwards, there's plenty of fuel because there's a lot of productivity. The fires don't come very often because it's so wet and cool up there, and so it's climate limited, right? And so fires didn't occur very often, occurred every 100 to maybe 300, 500 years in some cases. But when fires did visit the landscape, they were very intense. They were crown fires, and they were very large and stand replacing patches. And the fires that we see right now burning in the Cameron Peak fire up around Cameron Pass, and then the Mullen fire in southern Wyoming, these are actually fairly characteristic fires. These are under the conditions where all those fuels that have accumulated over many, many years are now available to burn. So hopefully that provides you some basic kind of understanding. So why are fire regimes important? They do provide this baseline understanding about why, where, under what conditions fires burn in an ecosystem. Okay, so ecosystems are not the same in terms of their roles of fire and how frequently they burn and the kinds of fire. Fire regimes also help us understand how a forest might change as a result of fire. Right? So if you have lower intensity, more frequent fires, we can understand that there's some trees left to be able to provide seed sources for the next forest to regenerate. And that's kind of their adaptation strategy. As you move up into ecosystems where fires are less frequent but more intense and higher severity, they tend to then have larger patches, and then the trees come back in more even-aged stand conditions. So fire, even severe fires, are a natural part of Colorado's forests. The forests that we see here, at least all across the Front Range and even across the state, they wouldn't be how they are without fire. Okay. So last thing I'll say about fire regimes is probably some questions that folks might have is, how are fire regimes changing? And again, if you look at the fire regime triangle here, ignitions, atmospheric conditions, and resources to burn, we know that from a variety of recent studies that there's increasing numbers, frequency, location, and seasonality of ignitions because of humans. Humans are the primary igniter of wildland fire. And we're just seeing a massive growth in those human ignitions everywhere across the landscape, and many times of years that lightning would not have ignited. Our atmospheric conditions are changing. We have longer fire seasons. This is well documented now. We now have fire seasons that are extending into October, November perhaps. We have fires that are now starting in February. And so our fire seasons are longer, and there are more days within that season that are conducive to rapid fire spread, even as we go up in elevation because of higher average temperatures. And we have more things to burn. We have an increase in flammable fuel. We certainly have increasing vegetation out there, as well as human-made structures out there that are capable of igniting and carrying a fire. And these are due to a whole variety of natural and human factors. So again, I know that any of these topics can be kind of a seminar on their own, but I just wanted to kind of introduce those right now to give us a framework for understanding what we might be seeing in terms of changing fire regimes. Okay. And so even though we might have historical fire regimes, you know, how things might, patterns that might have occurred over the last few hundred years, they're still pretty relevant in forecasting possible future scenarios, especially on the Front Range. So we might see more frequent fires moving from the lower elevation, drier forest types moving upwards because we're seeing different changes in our seasonality, in our atmospheric conditions, in our drought conditions, and those kinds of things. And so we may see increased frequency, intensity, and severity. As a result of that, we might see a change in forest composition and maybe a conversion from forest to non-forest in some places. And in fact, we are already seeing that in places like the Hayman fire, which burned in 2002, just southwest of Denver around the Cheeseman Reservoir area, where we're not seeing in some of these very high severity patches that burned off all the trees, we're not seeing very much or no regeneration at all. So we might be seeing some places converting to non-forest. Okay, so that's kind of a big picture, kind of 30,000 foot overview of fire ecology, kind of fire regimes as a construct, and then the fire regime triangle. So now I'm going to move to fire behavior. And again, this is another field of science where there's a lot of people that have been working on these things and characterizing the physics of fire and how it moves across the landscape. So I will just provide kind of the basics here. So fire behavior as a terminology is basically a way to describe and measure fire as it moves across space and time. So there's a distance and a spatial component as well as a temporal component. So the common two measures of fire behavior are intensity, and it's measured in terms of amount of energy released per unit area, per unit time, kind of BTUs per meter per minute or something like that. But the surrogate is we can measure intensity through flame length. How tall and how long a flame is a good measure of how intense that fire is burning. So then we have the second measure is rate of spread. So how quickly is that fire moving over space over time? The other ways to describe fire behavior is the types of fire. We have ground fire, so there's fires that burn in the ground as a result of some duff layers moving, and so you might only see the smoke, but you might not see the flame. But fuel is being consumed in the ground. Then you have the surface fires, and then you have the big crown fires that produce those dramatic flame lengths. So we're looking in this right-hand picture, flame lengths of 150 to 200 feet, which is obviously a very high intensity fire. So what influences fire behavior? When we see fires moving across the landscape, see videos on TV or YouTube or something of these recent fires, what are we looking at? What governs that? In fire science, fire behavior triangle is kind of probably tattooed on a lot of firefighters' arms, and we kind of really enculturated to understand fire behavior through the fire triangle. And it's topography, so it's kind of the landscape and the landform in terms of slope and aspect. It's the amount of fuel, the type of fuel, the amount, the arrangement, the continuity over space, and how dry that fuel's. So there's a variety of ways we can measure the characteristics of fuel and how available it is to burn. And then you have to have weather conditions that are conducive to fire growth and fire spread. So wind is obviously one, hotter temperatures, low humidities, lack of precipitation. And so changing degrees of each, and especially increasing degrees of each of these variables, and in combination with each other, will exacerbate fire behavior. And so your picture on the left-hand side, where there's kind of a surface fire and kind of a moist condition, fairly flat ground, not a lot of fuel to consume on the ground. There's a little bit of torching in the background, but that kind of explains kind of a very low intensity behavior. But then this graphic in the middle shows how slope really can be a driver of fire behavior. And then when combined with wind flows, that can be a real driver to exacerbate that behavior. And then the picture here on the right is a colleague of mine in the Forest and Rangeland Stewardship Department, Karina Pukonen, took from Rocky Mountain National Park, looking north towards the Cameron Peak fire, and you can see, steep terrain, very dry, windy condition, lots of beetle-killed trees, and just dense vegetation in general available to burn and producing some very intense fire behavior. So, fire triangle. And the fire triangle helps us to explain that why fire behavior and the severity of its effects can actually vary very greatly over very short distances due to those alignments of wind, of topography, wind, and fuel. So these are aerial pictures that I was able to take courtesy of Lighthawk, which offered a flight to fly over the Hyde Park fire in the summer of 2012. And so the top pictures are kind of towards the west end of the fire, up around West White Pine and East White Pine Mountain, where you can see fairly large patches of high severity burn, but also then intermixed with kind of lower severity patches and even unburned areas. Okay, and so kind of from a very zoomed out picture, you can even see a lot of patchiness and a lot of variability in the fire behavior and the fire effects. And then even when you zoom in very closely, in a matter of maybe a couple hundred yards, you see differences in fire behavior and the effects of that behavior. And so even within a couple of tree lengths, you can see fires didn't burn versus fire that consumed the entire area. And this is an area that we kind of had some conversations with firefighters. They were not in that area during the time this fire moved through, so there was not any direct fire suppression or anything like that. So these are the kind of fire behavior that we saw unmitigated by firefighter effort. So if we think about why is this important, right? Why is fire behavior important to understand? So for firefighters, obviously, it's very important to understand where you are on the landscape, what the wind conditions, what the fuel conditions are. They work on that stuff all the time. But for a lot of folks that may be on this presentation, for property owners, thinking about where you are on the landscape, how you might be aligning with the topography and prevailing winds and available fuels. Also, if you're interested in just the ecology of the area, what might we expect to see with these alignments of topography, weather, and fuel, and how it might impact the things that we might care about ecologically. So fire behavior becomes a very powerful tool for us to understand not only how a fire moves across the landscape during a fire, but what its effects might be on things we care about. I did want to just kind of talk a little bit about some of the large wildfires and some of the extreme fire behavior, because I think it's definitely relevant right now where we're seeing very large explosive growth in fires. And so one of the things that that fire scientists work on and look at is kind of how fires essentially create their own weather, create these cumulus clouds that draw in air and create their own energy systems, can even spawn their own lightning storms and start new fires elsewhere. And so this is a photo pulled off of a Twitter feed of the Williams Fork fire from a pilot, and you can see how the plume is getting way up there, right, almost hitting the jet stream there. We see just, kind of crazy fire behavior in terms of fire tornadoes. This was very well documented during the Carr fire in the summer of 2018, where we saw some firefighter fatalities as a result of kind of these unexpected wind-driven fire tornadoes. The other thing that large fires are, any fire that really generates some growth and heat is embers, and even when you're sitting by your own campfires, you know that there's little sparks and firebrands that fly off. So if you can imagine a large wildfire burning across a landscape, generating that kind of firebrands and carried by winds aloft, can then drift into other unburned areas and ignite new fires. And so spot fires is a real big concern, and that's in fact, I was just reading some reports from the Cameron Peak fire. There were some spot fires that occurred spotting in the last few days because of the warmer and drier conditions up there. Embers are also a real concern for structures in the face of wildland fires, and such that a variety of research studies have shown that firebrands are actually probably the leading cause of home loss in wildland fires burning into developed areas, what we call the wildland urban interface. So it's not necessarily the flaming front that is consuming homes, but it's firebrands and embers that are oftentimes the main culprit that's driving home loss. And so there's a variety of organizations that are really carrying out a variety of educational campaigns and a variety of fact sheets that really try to increase the awareness of property owners and homeowners in the wildland urban interface about how to become ember aware, and really mitigating the effect that embers might have on home ignition. So why do these things matter? Why do fire ecology, fire behavior, why should people care? What's really the important takeaways here? The first takeaway is fire. Again, fire is a natural, essential, and an inevitable part of our ecosystems here in Colorado. Again, the forests that we see, the landscapes, the ecology, they all really have a relationship with fire. Fire regimes, both fire regimes and fire behavior, are influenced by a complex alignment of factors. You have to have ignitions, you have the right climatic conditions over time, as well as weather conditions during a fire, fuel conditions, and especially for fire regimes, those factors are changing. And they're changing due to a variety of other compounding conditions and factors. The point of me saying that is these are wildland fire is a very complex phenomenon. There's a lot going on about why it's being caused, what happens during a fire. I think there's a tendency to look for easy solutions to stop a fire or to somehow influence how we interact with fire. And it's not so simple as just one single solution. There's a lot that's happening out on the landscape. So getting to that, what can humans do? What can we do to alter fire regimes and fire behavior? The things that we can control, if you think about the fire triangles, the only things within those triangles we control are human sources of ignition and the amount and arrangement of fuels in certain areas to be able to modify that fire behavior. And we can use science as well as collaboration with multiple stakeholders and managers to achieve some of those desired outcomes. So I'm going to end my talk talking about a few of those things. And our next set of speakers are going to talk about how people can alter their exposure and vulnerability about the things they care about to those fires. So in addition to doing some modification of fire behavior on the landscape, there's a lot that we can do in terms of property owners and homeowners to be prepared to respond to and to be able to understand our exposures to fire. So reducing human ignitions, right? It kind of comes back to Smokey Bear. Smokey is kind of a mal-aligned, treated figure these days. But Smokey's main point is to put out your fires, don't play with matches, do your part in really limiting ignitions of human ignitions. This is pulled from Summit County. So those of you who are in Summit County, kudos to you for having a great poster and really having some educational and outreach campaigns for reducing fire ignitions. And I think what I like about this poster is it clearly says more than 80% of wildfires are caused by humans. And so when we think about kind of these really dramatic fire years like 2020, human causes of wildfire, that's preventable, right? Those are things that we have control over. So in terms of modifying fire behavior and fire regimes, what we really then have to talk about what are our goals and what are the tools that are appropriate for those goals. So we have to really set and align our expectations really well. There's a great, one of my go-to scientific papers, Reinhardt and all, Elizabeth Reinhardt and many co-authors, they really specify and define that the objectives and the focus of modifying fuels, doing fuel reduction projects like the ones here on the left, are really to create the conditions in which fire can occur, right? It's to accommodate fire, but without those devastating consequences, rather than creating conditions conducive to fire suppression. So it's creating conditions where fire can occur, but occur in a way that is not destructive to humans or to the environment. Other common goals are things like reducing the likelihood of total forest cover loss, right? We don't want to, that might be a goal, or reducing the severity of soil burn. So really maybe using some methods to reduce fuels on the surface so that the soils don't burn so intensely. So those are some common goals we often see when forest managers, land managers, and fire managers write plans for how to deal with fire risk. We see these as goals. The tools that we have at our disposal, we can use mechanical tools or manual people to thin out forests, to reduce brush, to reduce that fuel load, and then take it out of the forest. So that's kind of an example here up on the top from the National Park Service, using hand crews to thin out the forest, reduce those ladder fuels, aggregating those fuels, and either removing them or putting them in piles to burn during the winter. And so you can kind of see how the before and after pictures would have a huge effect on reducing fire intensity as a result of those projects. Using for prescribed burning, these are prescribed burning is when managers intentionally start a fire under specified conditions to reduce those fuels, especially on the surface. And then managing wildland fire. So there might be a lightning start in an area under the right conditions that there might be able to be safely managed, and then be able to reduce the future fire risk in those areas because that fire was able to do the work of reducing those fuels. So deciding where and when that's appropriate requires a lot of planning, requires a lot of scientific analysis, and requires a lot of collaboration and engagement with stakeholders who might be interested and affected by that kind of fire management. Fuels treatments do not, as far as goals that fuels treatments do not necessarily achieve, that's worth also talking about as well. When we go out and reduce fuels, it doesn't necessarily prevent fires from occurring. Okay, the only way we prevent fires from occurring in the first place is to reduce those ignitions, especially human ignitions. Fuels treatments don't necessarily affect the size of a fire, how big a fire is going to grow, or necessarily slow the rate of spread, and may actually increase the rate of spread. It doesn't necessarily reduce the cost of wildfire suppression either. There other factors go into how much a fire costs in terms of its suppression. And fuel treatments do not necessarily mimic ecological processes, right? Their fundamental goal is to alter the fuel arrangement so it changes the fire behavior. Again, this is comes from that Elizabeth Reinhardt paper. And so we know that because of those different alignments of topography, weather conditions, fuel conditions, before and after treatment, it really depends on how effective those treatments are relative to those goals. Okay. The other thing that especially partners that I work with and the Colorado Forest Restoration Institute, Southern Rockies Fire Science Network, we interact with a lot of folks that are really working on these problems on real landscapes here in Colorado. And we understand that there's a whole variety of factors that constrain our ability to do work. There might be environmental, legal, financial, social factors, and it might not be feasible or even desirable to modify fuel everywhere to change that fire behavior. So the challenge right now that we are here in 2020 is really drawing on the best available science, really interacting as a community of practice and of citizens of concern, targeting areas and implementing the combination of treatments that are most likely to be able to modify fire behavior to maximize benefits and minimize harm to people and ecosystems. And so one size doesn't fit all. We really have to use a whole variety of tools in our toolkit to be able to decide where to do work to have the greatest effect. So this is just some examples of work that my organization is involved in at CSU. The Colorado Forest Restoration Institute is a large collaborative effort among a variety of organizations and science groups to define some principles and practices to restore fire back to these seasonally dry forests, the ones on that lower elevation part of the gradient. Again, so it's bringing back fire in a way so that it can play its natural role, but doing it in these strategically planned locations so that they really minimize negative effects on people and the things they care about. Right. And so again, using tools to reduce those fuels so you're not seeing complete forest loss, but accommodating fires to be able to move across the landscape in ways that are beneficial socially and ecologically. Just looking at the Cameron Peak fire, the footprint of the Cameron Peak fire, this is about 4 days old or so. And so in the pink is the Cameron Peak fire, and the black outline that you see here are old fires around the Fort Collins area. So just for you non-local people not familiar, this is the city of Fort Collins, Horsetooth Reservoir. This is Highway 14 in the Poudre River Canyon here. This big blob here is the Hyde Park fire that burned in 2012, and then a whole bunch of other kind of smaller fires. We actually think about them now as small fires, but back in the day they were pretty big fires. And so you can see that when the Cameron Peak fire hit the western edge of the Hyde Park fire, because there was a lack of fuel really to burn, that fire kind of petered out, right? That western edge kind of held that fire. But look at this little blob in here. What's going on here and what's going on there are two prescribed fires that were ignited by the Forest Service. One of them is called the Dad Bennett prescribed fire that was ignited and burned over a period of 3 years in the late 1990s, early 2000s. And then the second fire is the Pingree Hill fire just east of the little community of Rustic. That was ignited and managed over the last 3 years up until just last year. Just looking at those, the caveat I'll make is that, these are just very preliminary estimates, just looking at the GIS and the perimeters. But it looked like those prescribed fires helped mitigate and that intensity and that spread a little bit. So managing fire with fire through that prescribed fire at a scale that really made a difference. But clearly more research, we need more research to really to gauge the effect of this and any other treatments. I know that there were other treatments that the fire burned into, prescribed fires that blew right through those treatments, but they might have burned with lesser intensity. We're just going to have to get out and see and do some field measurements. The second caveat is that it's not feasible or appropriate to do these kind of big prescribed fires anywhere and everywhere. Again, they have to be strategically located in ways that are going to make a difference to modify fire behavior. But this is just just wanted to provide you just a few things that managers are really working on and using the best available science, interacting with a variety of jurisdictions and stakeholders to try to make decisions to match the actions to match the scale of the kind of fires that we are looking to expect in the future. So that's the conclusion of my presentation. Hopefully, my hope as a extension agent, as a specialist and an educator, is that my presentation did achieve these learning objectives. And at this point, I will stop talking and open it up for questions.
Great, Tony, thank you. If you want to go ahead and put your last slide up, you can. I think we can still leave that up if you'd like.
Sure thing.
Just because it has what's coming up next. I think you, one more slide, right? No?
There it is.
Yes, there it is, okay.
Oh, there it is, okay.
Yeah, we can go ahead and leave that up so that
okay.
people, know what's coming up and they can plan for the next 3 presentations if they're interested.
Fantastic.
Thank you so much, Tony. That was very, very interesting. I think I learned a lot, and I'm sure our audience learned a lot. It was really good information to have, kind of the background information of what's been going on and what we might look at in the future. I'm going to go ahead and give folks a couple minutes to enter any questions that they may have in the chat. And while they're doing that, I'm going to go ahead and ask you a question that I thought about as you were giving your presentation. First of all, the fire behavior triangle was fascinating to me because you've got, you know, those 3 perfect sides that when they come together, they create that perfect storm. And if you don't have one, you don't have the other. So I thought that was really interesting to look at all the different components that went into that to kind of create that perfect storm to create the wildfires. So what I was going to ask you about is, you know, you kind of ended it on the prescribed burns. I know there's a lot of, you know, pros and cons to doing that. Are you thinking that we may be moving into having more prescribed burns into the futures as we're seeing more of these really intense fires, or are we still not sure the direction we're going to go with prescribed burns yet?
Yeah, I mean, there's, you know, there's a lot of compounding dimensions to the answer to that question. You know, there's a variety of political and policy and legal questions. There's a lot of social acceptability and kind of safety and security questions. And then there's also just kind of the capacity of our fire services and land managers to be able to, you know, plan and enact these kinds of projects on the Front Range or anywhere else. Prescribed fire is a tool in the toolbox, right? It's kind of, I kind of equate it as like a you know, a hammer or a sawzall in my tools. And it really depends on what I'm trying to achieve, where and when and under what conditions. And so a sawzall can be a great tool when I want to achieve a certain something, but when I'm trying to do something else, a sawzall would be a pretty reckless tool to choose. And so there's managers that have a lot of experience with prescribed fire, they really understand that. And I think one of the things that is important is to really start building out that understanding and that capacity to know where and under what conditions would prescribed fire be a useful tool. Because I had mentioned in the others in my slide, it's not appropriate anywhere and everywhere. And so
Right.
we're developing definitely kind of a variety of spatial analytical tools using GIS, using kind of advanced quantitatively based wildfire risk assessments to know kind of where might prescribed fire be the most effective and efficient tool to mitigate that fire risk, and really strategically target those areas. Not kind of, it's not something that we would do everywhere and anywhere all the time.
Right, right. Okay, thank you. So I've got a question here from someone in our audience, and they're asking, what is aspect?
Aspect is either north facing or south facing or west. It's the orientation cardinally where that slope is pointing.
Great, thanks. Next question, any news on insurance coverage in Colorado?
No, not for me. I know this is a big topic. I know in California, insurance companies are dropping coverage of people living in fire-prone areas. I think that's definitely worth maybe a presentation from maybe someone from the Rocky Mountain Insurance Association.
Mm-hmm.
I think especially after a fire season like this, it's always good to hear from our insurance colleagues.
Right, right. Mari, I'm gonna invite you to jump in if you're getting questions that I'm not seeing. I don't have any more questions here, but she may be getting some that I'm not seeing. So I'm gonna let her jump in if that's the case.
I don't have any others right now, Karen.
No others? Okay. All right. Do we want to give everybody a couple more minutes to go ahead and put questions in the chat if they have questions for Tony?
And also, you know, while people are working on that, I guess, you know, as extension agents in working in counties, working very closely with homeowners and landowners, what are some of the common questions you hear about?
So what I hear about have to do with the land following the fire.
Hmm.
So it's not the cleanup. It's you know, what do I do with dead trees that are on my property, trees that might be dying? How do I reseed? Everybody wants to reseed. Everybody wants to get the property back to not what it looked like before, but not quite such a moonscape. And so this is the second major fire that I've gone through in Larimer County. We had the Hyde Park fire in 2012. And so from a landowner's perspective, that's what I deal with mostly. And then obviously the flooding aspect of it, which is, you know, depending on the severity of the burn, rains that we get. So that's what I typically see from an extension agent point of view.
Yeah. Yeah, I mean, I think that post-fire kind of land recovery and restoration, that could be a worthwhile Wildfire Wednesday talk. You know, there's an awful lot of people now with, you know, both kind of scientific as well as practical experience in terms of, you know, what do you need to do, what are effective approaches, what are maybe approaches to avoid, and that could be an interesting topic for folks to hear. I do know that for the Cameron Peak fire, there, because of the Hyde Park fire, there's already kind of a built-in group of people, a network of authorities, you know, within the county, some of the city water providers, roads and bridges, transportation people. The Coalition for the Poudre River Watershed is Jen Kovexis and her team. Some folks from CFRI are providing some post-fire erosion modeling products. USGS has some debris flow modeling. So I know that there's a lot of folks working on the technical aspect of that and looking at what, where, and when these risks might occur. And again, maybe once things settle down and there's some snow on the ground and people have a chance to breathe, that might be another good Wildfire Wednesday presentation.
Yeah, no, I agree. And I think just talking ahead, next week we have Daniel Beveridge from the Colorado State Forest Service, who's going to come and speak on defensible space and home hardening. So he is going to provide a lot of very good information to people to help them understand what they can do around their home to better prepare it in the event of a wildfire. And then the next week we have Irene Shanley, who is an extension agent with CSU, and she's going to be talking about fire resistant landscaping. So kind of, in my case, where people have been affected by wildfires and want to put in a landscape, how to do it the best way that they can to help reduce that. So next week we have Daniel that's going to talk about the inside and surrounding the home, and then Irene is going to come in and talk about that landscaping.
Yeah.
So I think that those will be really good topics to help folks with.
Yeah, absolutely.
So I do have a couple more questions, Karen, that came to me.
Perfect. Thank you.
Tony, could you talk about fuel moisture measurements and fuel size?
Yeah. So this is extending at the very boundaries of my knowledge, but fuel moisture is basically, if you've been around like campfires, even your fireplace, wetter wood is harder to burn than dry wood. And so you can measure that by taking dry weight measures, where you take a handful of fuels, you weigh it, and then you put it in an oven for a period of time to let all the moisture evaporate, and weigh it again, and that gives you a sense of what the fuel moisture content of that fuel is, and then you can correlate that with how ready is that fuel to burn. And then, so that's sort of one way to do that. And then you can take different sizes of fuel and kind of extrapolate the measurements of that. So they talk about 1 hour fuel, 10-hour fuel, 100-hour fuel, and 1,000-hour fuels as kind of ways of measuring size classes of fuels available to burn. And so it's just the drier, the less moisture that a fuel has, the more available it is to burn. So hopefully that answered that question. And then the second question, Mari, can you help me out?
Sorry, yes, fuel moisture measurements and fuel size.
Oh, fuel size. So I think I just mentioned that there are different classes of fuel, from fine needles all the way up to big logs and tree, and especially the ones that are on the ground are ones that people really care about, because that's what's carrying that fire energy. So you have, yeah, just those classes of fuels are from 1 hour to 1,000 hour.
And then the next, oh, sorry.
Oh, no, that's okay. I just had a question pop up here, Mari. I don't know if you were going to ask this or not.
Go ahead.
So does the fire behavior triangle model let you predict the path and intensity of the fire, or is it mostly post hoc explanation?
So there are folks that work on fire behavior, and there are a variety of fire behavior models that take all these measurements that I was talking about in terms of fuel amount and availability, topography, and wind, and they kind of they plug those into equations to estimate the intensity and rate of spread that a fire would be predicted to produce as a result of those inputs. And so there are fire behavior analysts and fire people running those kinds of models in fire camps. So the incident management post here on the Cameron Peak fire, people are looking at these fire behavior models to estimate what kind of intensity and rate of spread can be predicted as a result of those inputs. Yeah.
Good, thank you. Mari, did you have another question?
Yeah, how much moisture and time do you need to replenish fuels?
For them to grow back? I guess I don't know. I'm not sure I understand that question.
That's kind of
totally.
that's the way I took it. William, could you clarify in the chat? Well, I am actually curious about that, Tony. If that is his question, is I know there's been some research done on the Hyde Park fire and how slowly that burn was to recover.
Yeah.
Is that sort of the direction most fires are headed, just based on intensity now, or?
Yeah, so there's, several colleagues here. One, Maren Chambers at Colorado Forest Restoration Institute, Paul Fornwalt at the Rocky Mountain Research Station have been doing quite a bit of research across the central and southern Rockies here on looking at post-fire recovery. And so they've gone to look at fires that burned in the early 2000s at various sizes and various intensities and severities. And in some of those big high severity patches, especially in that ponderosa pine dry forest type, we're not seeing any tree regeneration and growth. It's kind of still kind of a grassland, shrubland in the middle of some of those areas. It really does then depend on available moisture and soil productivity, seed years, especially for heavier seeded tree species like ponderosa pine. Masting year, kind of seed production years are every 7 years or so. And so those every 7 years then also have to coincide with some kind of wetter conditions for those seeds to be able to establish in the ground. So you have that alignment again of seed availability and kind of atmospheric conditions that allows seeds to be able to germinate and grow. That's also kind of things that ecologists are keeping an eye on, because we're seeing changes in those conditions as well.
Okay, William did clarify.
Okay.
So will we be able to replenish our fuel moisture this season, or is the drought too extensive and lasting?
Oh, that's a good question. I don't know, right? Yeah. I mean, I think it's very, very tied to drought.
Yeah.
And so, keeping an eye on, a lot of folks keep an eye on what's called the Palmer Drought Index. Or Palmer Drought Severity Index, and that's put out by the USDA. There's a variety of measures that go into that. But right now, here in Colorado and the Central Rockies, we're either in the extreme or the severe drought right now. And it takes a lot of moisture to move from those categories into moderate to mild to no drought at all. And it's looking that way across a big chunk of the West, right? So it's not just Colorado that we're experiencing severe and extreme drought. It is a kind of subcontinental scale challenge right now.
Yeah, and just if anyone's really interested in looking at what the drought is doing currently, every week they update the U.S. Drought Monitor map, and you can Google U.S. Drought Monitor map, and it will show you Colorado, and it will show you the entire country, but the west part of the country especially. And in Colorado, it will cover county to county, so you can actually see what your county is doing as far as where we sit on that drought monitor map.
The other thing that is, kind of interesting to note, and I just sort of thought of this, but just kind of plug into people's thought, is that when I'm a skier, so I keep track of snowpack. A lot of people on the call are probably also skiers. This year, the last season, the 2019-2020 snow season, was actually a good snow season. And the Cameron Peak and Joe Wright Reservoir, where there's snow tell gauges and those kinds of things, it was a very good snow. Northern Colorado got a lot of snow, and it stuck around for a long time. And so we were wet, and we were not in that drought condition. But that situation can change within a season. And I think that's something that we did not see, kind of the wet, cool monsoonal flows that we might usually see, and that kind of warm, dry, windy condition towards the end part of the summer. It doesn't take much to go from really lush, kind of happy conditions to a situation when there's a lot of available fuels. The other thing is you have trees that have been impacted by the spruce beetle and the mountain pine beetle, and so their moisture content is already really low because they're not drawing in water. These are dead standing or dead, fallen on the ground, and so those fuels they're not holding that much moisture anyway. Even if there's 10 feet of snow on the ground, once that snow's gone, those fuels will dry out quicker just because they don't have a lot to begin with.
Right. Thank you. Mari, are there other questions? I'm not seeing any at my end.
I don't have any others at the moment.
Okay, then I think we can go ahead and wrap up, Tony. I want to thank you so much for presenting this information. It was really valuable, really helpful for people to understand kind of what's happening, not only just with our droughts, but just how these fires are really impacting us. I think it's just what you presented was something most of us don't ever hear about. So it was very valuable. I appreciate it very much. Thank you.
Thank you, and thank you for the invitation.
You're welcome. And I just want to remind everybody, next week we have our defensible space and home hardening presentation, and that will start at 6 o'clock, same time, same Zoom link. So go ahead and just sign in to that link. You should have the link for all 4 of the presentations, and we will look forward to seeing you next week, everybody. Thank you.